Hello, my name is Josh Obert, and I am a GIS analyst with the ACPF National Hub. In this video, we will go over some necessary steps to set up the ACPF Toolbox before we begin running the tools. We will also look at the initial data needed to start running the tools. This will involve downloading the ACPF Toolbox and the user manual, downloading the TAU DEM software that is used for some of the ACPF tools, loading the ACPF Toolbox, setting up our ACPF folder directories, and then making some adjustments to our workspace and geoprocessing settings. So let's go ahead and get started. We will start by going to the ACPF project webpage. The web address is acpf4watersheds.org. We will download the latest toolbox and some of our initial data from this webpage. Once we are on the main page for ACPF, we will click on the three lines in the top left corner of the page to produce a drop-down of options. Under the Use category, we will see Download ACPF. We will click this link. After scrolling down on the Download ACPF page, we will come across four orange buttons. The first three of these buttons are to download different versions of the ACPF Toolbox. The last button will take us to download the core data for our watershed. The current version of the ACPF Toolbox is version 5 and can be downloaded from the third button. A list of the enhancements found in version 5 can be found above the buttons. Due to differences in how toolboxes are created in ArcGIS Pro version 3.0, version 5 is only available in ArcGIS Pro 3.0 or greater. We will still provide access to version 4 for ArcGIS Pro versions prior to 3.0. We also provide a version 4 for ArcGIS Desktop, also known as ArcMap, for 10.7 and newer. By clicking the button to download the latest version, a new window will open, taking us to the University of Wisconsin box site. At the top of the screen, we will see a button to download. Click that and the download will begin. You may be asked to save your download to a location. Once complete, we will have a zip file that contains the toolbox, the user manual, and other information we will go over later. Let's close this window so it will take us back to the Download ACPF page. And let's click on the last button in the row, Download ACPF Core Data. This will open a new window containing the ACPF Core Data download application. On this page, we will click OK to dismiss the splash page. We will see a panel asking for information to proceed to download. This information is not needed to just view the application and data. However, it is needed to download the data so that the National Hub can keep metrics of who is running the toolbox. For more information on how to use the application, you may expand the How to Use box on the right side of the window by clicking the double down arrows. We will enter our information and click Submit. We are presented with the ability to download by HUC 12 or HUC 8, but we will be downloading by HUC 12 for this example. For our testing, we will be using the watershed Dutch Creek, Wapsipinicon River with a HUC 12 ID of 070801030201. This watershed is located in Jones County, Iowa and contains the city of Anamosa. The map of the application at the default scale shows the HUC 8s in purple that contain watersheds with available core data. We will look at what constitutes the core data later in this video. At the top of the map, there is a search box. This search box allows us to enter the partial name or HUC ID of a watershed to quickly find our watershed of choice. Type Dutch into the search box. We see a list of 5 watersheds that contain the word Dutch in the name. The second record in the list shows the watershed we will be using. Let's click the name and the map zooms to the located watershed. The map is centered on our clicked watershed as we can see the name and ID of our watershed. We can also see that the watershed is in Jones County and contains the city of Anamosa. Before we download our watershed, please make sure that pop-ups are enabled in your browser. If they are not, the download may get blocked by the browser. To select a watershed to download, we will click the gray Select box in the Select HUCs to Download panel. The Select button will turn green when it is activated. We will also be presented with a small window next to our mouse cursor stating press down to start and let go to finish. Let's press and hold the left mouse and drag to create a blue box staying within our test watershed. Let go of the mouse and our watershed will be selected by turning light blue. We can also see in the select panel one watershed has been selected. Later, if we want to select more than one watershed, we would make the box big enough to select multiple watersheds. Now that the watershed is selected, we will click the download button in the panel. When we click download, a blue preparing download message will show, letting us know the application is working behind the curtain. A red download complete message will show once the watershed has been downloaded. You may be presented with a window asking you to save your downloaded watershed. If you get that, we will click save. There's the red message for download complete. We should also see a download progression window. Let's move on to downloading the TAU-DEM software. TAU-DEM is a software developed by David Tarbotten and Utah State University, and it can be accessed through their website. In order to run the ACPF, TAU-DEM must be installed on your computer. If we go back to the Download ACPF page and scroll down this page more, we will come upon a section titled Software. In this section, the National Hub has placed a link to download TAU-DEM. The link states download TAU-DEM at no cost through Utah State University. If we click this link, it will take us to the home page for TAU-DEM, and then we'll need to click on the Downloads tab to get to where we download the software. We're going to want to make sure that we download the TAU-DEM most recent version of the complete Windows installer. For this version, that would be TAU-DEM 5.3.7 complete Windows installer. The ACPF uses this software for a number of reasons, including its ability to process on multiple computer cores at once, as well as some enhanced terrain processing abilities. Make sure that you install this before running any tools. However, I will not be showing you how to install this software during this video. We have downloaded everything we need to run ACPF. Next, we will take a look at the toolbox that we downloaded first. We will go to where we download the toolbox and unzip it. I had downloaded it to my downloads folder and will use 7-zip to extract the zip file. We will right click on the zipped toolbox named ACPF _V5 _Pro _04042023. This just shows that it's version 5 of the ACPF. It's for Pro and the data which it was uploaded. We will then go to 7-zip and choose extract here. If we scroll down to our downloads, we will find that there will be a folder titled the same thing that the zip file was, ACPF V5 Pro 04042023. We will open that folder, and the first folder we see in the toolbox folder is titled Docs. I highly recommend everybody read through the user's manual that is within this Docs folder. There's important information in the manual on the theories behind the ACPF, as well as how each tool runs. The manual also describes what inputs are needed for the tools and what outputs you will get, including explanations of all the attributions for each output. I would recommend having this user manual open and using it as a reference when you're running through the ACPF the first and even second time, so you can understand what the tool is doing. There is also a layer files folder containing example symbology templates for ACPF outputs. We also have a metadata folder, which contains the default metadata that will be used to populate the metadata for our tool results. And then our last folder is the scripts folder. These are all the Python scripts that are used by the ACPF tools to run. You will likely never need to edit these scripts, but if you do, it may change the way the tools will run. Back in the main folder, there's also a text document that has instructions on how to install the ACPF Toolbox. We will be going over this, but it's also here for your reference if you ever need a refresher. There is also the ACPF crop data layer lookup table. This is used to format the NAS data that we will use within the ACPF. And then finally, the actual toolbox with the extension .atbx, which we'll be installing into our ArcGIS Pro interface. Once unzipped, we will move this folder out of our downloads folder. So if we right click on the folder, copy, and what I will do is place it in the C drive. The ACPF Toolbox should be stored in a permanent file location on your computer. This means not on the desktop and not on a network drive, in the same data structure that the ACPF Toolbox was obtained. This means that you have the base folder of the toolbox with all the other internal folders and files still in the same directory. In addition, the path name to the ACPF v5 Pro directory should not contain any spaces. This is one of the reasons why I like to keep the toolbox at the base of the C drive, so that is why I put it there. We also want to make sure that we store the ACPF data, like the toolbox, on a local drive and not the desktop or a network drive. We can create an additional folder at the base of C called ACPF_data. We right click, go to new folder, and we will call that ACPF_data. Back in the downloads folder, right click on the watershed zipped file and go to 7-zip, extract here. Once it's done extracting, we will scroll down and we will see a folder titled ACPF our HUC12 ID number .gdb. We will then move this extracted geodatabase to our ACPF data folder by right click, copy, go to C, ACPF data, right click, paste. Let's open a new ArcGIS Pro project so that we can take a look at the contents of our watershed geodatabase. To view our geodatabase, we will need to make a folder connection in our catalog window within ArcGIS Pro. My catalog window is visible to the right side of ArcGIS Pro. If you do not see your catalog window, go up to the top menu bar and click View. Right below that, in the View toolbar, is a button titled Catalog Pane. When we click Catalog Pane, the catalog window will open. With the catalog window open, we will right click on Folders and click Add Folder Connection. We will navigate to where we are keeping our data currently. For this example, we will go to C, ACPF data. I want to point out that our geodatabase cannot be a direct folder connection. As we can see in the window that this says the container is empty. It's because the geodatabase will not even show us an option. So we need to choose the parent folder, which is ACPF data. And then we will click OK. When we expand folders, we can now see the ACPF data folder is a folder connection. And if we expand it, we will see our geodatabase within. The file geodatabase that is downloaded from the ACPF website contains what is known as the core data. We will look at each of these items individually shortly. This file geodatabase is also the location where all the outputs from the ACPF tools are going to be directed to. Every single data piece has a base name, and then a majority of the data are also followed by the 12-digit HUC ID. If we expand the geodatabase, we can see that visualized. All output names will also end with this same 12-digit HUC ID. When you're running the tools, you may optionally change the base name if something makes more sense to you, or say you're rerunning the process a few times over. However, you'll want to make sure that everything always ends in this 12-digit HUC ID. Some of the tools will automatically grab data and bring them in for inputs, and it's going to be looking for this ending, so it's very important that you keep the same file name structure. The core data consists of multiple feature classes, rasters, and tables. Let's take a closer look at the items within this file geodatabase. I will turn off the default base maps to allow better visualization of this data. We will add each of these to our map by clicking on each item and dragging from our catalog window into the map. First, we have the watershed boundary feature class, donated by the prefix BND. This watershed boundary has been derived from the National Hydrologic Data Set. We also have a buffered watershed boundary donated with the prefix BUF. This boundary is a buffer of 1,000 meters of the watershed boundary and the field boundary data set. This makes sure that it encompasses all fields that lie partially within the watershed. It is also used to clip all the rasters to the watershed extent. If we click and hold on the buffered watershed boundary and drag it to be below the boundary file within the table of contents on the left side of the screen, we can see a comparison of the boundary file and the buffered boundary file. Our last feature class is the field boundary data set, donated with FB. These were originally developed from the pre-2008 Farm Bill with all identifiable information removed. A lot of watersheds within the ACPF database have been updated to newer field boundaries that have been created by users. Let's take a look at the attribute table for the field boundary data set by right-clicking on field boundaries in our table of contents and going to attribute table. We can see a field boundary ID. This is a unique identifier that will be used to join a lot of the outputs or tables to this feature class. We also have the acreage of the field. We then have an isAg field, which contains values of 0, 1, or 2. 0 indicates non-agricultural. 1 indicates that it is cropland, and a value of 2 means that it's pasture or grassland. The update year can be found as a value to the reference year of the data that was used to delineate the boundaries. In this example, these field boundaries were delineated to 2021 imagery. You will have the opportunity to manually update these field boundaries within the utilities of the ACPF Toolbox. This will be found in a later video. Now we'll make our way through the land use data that the ACPF geodatabase provides. First off, let's take a look at a couple of the NAS crop data layer rasters. Each of these are developed by the USDA for each available year at 30-meter resolution. These will range from 2010 to the latest update provided by the ACPF National Hub, and what we do is overlay the field boundary with all these years available and then extract information by field. The NAS dataset contains over 100 values, so this gets condensed down using an ACPF lookup table. If you remember from earlier in the video, that lookup table was downloaded when we got the ACPF Toolbox. The next piece of land use data will be the crop history table, which is prefixed with CH. When we drag that into our map, we will need to open up the attribute table since that is what it is, a table. So right click on the crop history table and go to open. We can see our field boundary ID, and then all the other information within this table is about the major land use in each field for each year of the provided crop data layers, and the percent of the major land use that makes up each unique field. These are all codes from the lookup table, and the percent that cover type makes up. We can see we have the major land use for 2010 and the percent. And the values go all the way to 2022 for this download. The final piece of land use data that we have is the LU6 table. Once again, since it's a table, we will right click on the land use table and choose open. This table looks at the last 6 years of land use data for each field. Hence, we have the field boundary ID again. This table also contains a general land use field, an ag land use field, a 6-year crop rotation associated with each field boundary, a crop summary field which summarizes this crop rotation, and then a continuous corn count and a mixed ag count. If you want to know more about each of these fields and how they were generated, you can view the metadata for this table. Up next in our geodatabase is the soils data. The first item is the GSurgo soils raster. This is a 10-meter raster, and it has an attribute table as well. If we right-click on the GSurgo raster and click on attribute table, we can see there are quite a few fields that can give us information about the soil within each map unit. This data is broken down by map unit key, also known as MU key. This is a very valuable field, especially later on when you'll be joining soils tables to the GSurgo raster. The next soil data set that we have is the soil profile table. If we right-click on that table and choose open, we can see the MU key field so that we can join the soil profile table to the GSurgo raster using that as the join field. The soil profile table provides information at depth of each map unit, so we can get information such as available water storage and percent organic matter or coarse soils within each map unit. The next table is the surface horizon table. We open that table. We can see that again we have a map unit key. So we could join the surface horizon table to the GSurgo. This table provides information about the surface horizon. We also have a co-key, which is the component key. This is a valuable field if you are going to be joining the surface texture table, which is our last table of soil information. If we right-click and open that table, we can see that it has the co-key. So that is going to be our join. There is no MU key, so if you would like to join the surface texture table to the GSurgo, you will first have to join the surface texture to the surface horizon based on the co-key, then use the MU key from the surface horizon table to join it up against the GSurgo raster. We just went over all of the core data that comes with your ACPF geodatabase, but you may have noticed we don't have a DEM. That is the one thing that you will need to provide yourself. On this slide here, we have provided some sources that may have an adequate DEM for you, such as the USGS 3 depth viewer, but there are many more out there to explore, especially with state sources, such as the listed DEM downloader for the Iowa State GIS facility. Some key things to know is that the ACPF requires your DEM to be in whole meters. You will also need to be aware of your Z units, and this will not be contained in the layer properties, only in the metadata. The ACPF can handle any vertical units as long as a Z factor is provided. The Z factor is a conversion factor where it is the number of horizontal XY units within the Z unit. So for example, if you had a meters horizontal unit, but then a centimeter Z unit, your Z factor is going to be 0.01. That is the number of meters that fit into a centimeter. The ACPF does tend to work better if the Z units are in centimeters. It just reduces storage requirements and any issues with quantization. Another important thing to note is that the same coordinate system must be used for your DEM as it is the rest of the layers. The ACPF data is provided in UTM, so make sure that your DEM is also in that UTM coordinate system. Lastly, the DEM should be the same extent as the buffered watershed boundary, so you could use clip or mask to make it the same extent. Let's take a look at the DEM we will be using. This DEM was downloaded from the Iowa State University GIS Facility DEM download application, since it is an Iowa watershed. We are back in ArcGIS Pro, and within our catalog window, we can see our DEM is in TIFF format and has been placed in the ACPF data folder outside of our geodatabase. When you run any ACPF tool, the inputs should be coming from your ACPF geodatabase. To get our DEM inside, we are going to right-click on our DEM TIFF and choose Export to Different Format. This will open the Copy Raster tool within a new Geoprocessing tab in the same panel as our catalog. Our original raster is populated within the first input of Input Raster. The second input, Output Raster Dataset, needs to be set to our ACPF geodatabase. Click on the small folder that is at the end of the input box. We will need to navigate to our geodatabase. So on the left side of the directory window that opened, click Folders. These are the same folders that we saw in our catalog window, and we can see our ACPF data folder. Double-click that folder, and then double-click on our ACPF geodatabase. We will know that we are within the geodatabase when we can see our GSurgo and crop datasets. In the name input below the folders, we will enter the name of our DEM as it currently is. We can see that the name is up here in the input raster input, and we will enter that into the name box. Once the name is entered, we will hit Save. The output raster dataset is now set to our file geodatabase. We do not have any other settings to run with this tool, so we will go ahead and click Run at the bottom of the window. Once the tool has completed, our new DEM that is located within our geodatabase will be added to our map. If we right-click on the DEM within the table of contents and choose Properties at the bottom of the list, we can take a quick look at some of the properties. In the now open property window, click on Source on the left side of the window. In the right side of the properties, let's expand raster information. We can see that cell size X and cell size Y are both 1, which shows we have a 1 meter raster. If we scroll down and expand the spatial reference section, we can see that our DEM has been projected into the appropriate spatial reference, which is UTM Zone 15. If this was not the correct spatial reference, we could reproject the DEM to the proper coordinate system. And then the last important piece of information is the linear unit, which is in meters. You always want this to be in meters to have efficiently running ACPF tools. Click OK to close this window. Before running the tools, we are going to want to make some edits to our ArcGIS Pro settings. Within ArcGIS Pro, on the top menu bar, we will click Analysis. This will open the Analysis toolbar. In the first section, titled Geoprocessing, we will click Environments. This opens the Environments window, and we will be looking at the current and scratch workspaces at the top of this window. We will want to make sure we are happy with where these workspaces are located. We will also be checking to see if these geodatabases have the same format as their other folders with no spaces and not on a network drive. Most of the time, these will be in your Pro project default geodatabase. That is what we can see on my screen. And so if these are to your liking, you can just click OK. Next, we'll change some geoprocessing options. In the menu bar, click Project, and then click Options from the left side of the menu. In the window that opens, click on Geoprocessing on the left side underneath Application. The first checkbox in these options will allow geoprocessing tools to overwrite existing datasets. We want to make sure that this option is checked. This means if we ever want to rerun a tool that keeps the same name, it's just going to overwrite that previous output without having to delete the previous output from our geodatabase. Once this is checked, we'll click OK and then click the back arrow in the top left corner of the window to get back to our map. Now we can add our toolbox. To add our active toolbox, we'll need to make sure our catalog window is open. We will add our toolbox by right-clicking on Toolboxes and clicking Add Toolbox. We will navigate to the location of our toolbox, which is at the base of the C drive within our extracted folder. We will click to highlight ACPF v5 Pro.atbx and click OK. When we expand toolboxes, we will now see that our ACPF toolbox has been added to the list of toolboxes for our project. If you want to make this convenient and have this toolbox always load every time you open ArcGIS Pro, we can make this happen. When we right-click on the toolbox, we are presented with some options. If we click Add to New Projects, this toolbox will be added to all new projects and appear under the same toolboxes list when the project is opened. That's all for this video. To recap, we downloaded the ACPF Toolbox and data, discussed requirements to our folder structure, and prepped ArcGIS Pro to run the ACPF Toolbox. In the next video, we will begin preparing our digital elevation model for hydroconditioning.